Okay, now we will move to our third part. It was the building, training, and testing of CNN on CFR 10 dataset. So, what we did, like building, training, and testing of the CNN network on CFR 10 dataset was done using TensorFlow AI network and Python. And training was done with 5,000 step. Testing of the network was done with 100 step of training, and there is two layer, and training was done with 5,000 step. The training of the model so result is improved to 66.85 after every steps, and sometimes it is fluctuating, but at the end accuracy of 66.85 was achieved. So what is the steps? First of all, we have to set the path for the data folder. Then we have to load the data set. Then we have to display some of the images using matplotlib. Then we have to define some of the supporting function to rearrange the data. Then we have to define supporting function to build, train, and test CNN model. Then we have to build the phase 1 and phase 2. Phase 1 is the build convolutional neural network. Phase 2 is to train and test the CNN model on the CFR10 dataset. Okay, to understand it more clearly, let me go through some of the important steps we can see. So, what we have to import some of the important Python library, then we can get the data and data. One second. If we see, this is setting of the path, then loading the data, then we have defined the directories of all the 7 files. Then one by one we we went and extracted all the data. Then we have to do some visualization, and we imported the numpy as np. Then we can see this is the images, second images, third images. Then we have to encode label in, like we have to define some of the supporting function to rearrange our data. So to do that, uh, one second. So first we have to define the filter. Then we have to initialize the bias. This is a function. Then for the convolution layer, and then perform the computation. Computation means dot product x into w. So this is the function in which we took the filter size of 5 into 5 and 1 and 32. Then we have to set up the ReLU layer and perform the computation of the dot product plus y's xw plus v, this function. So we define this function. Then after that we have to set up a pooling layer and then reduce the spatial size. And then the other function we have to define is set up a fully connected layer and perform computation. This will set up a fully connected layer, and we have to perform. So basically it's a function, and it's perform the computation like dot product of the input plus weight plus y's and then return the result. Okay. And after that, the phase one comes. Phase one is the building of the network. So we have to define two variable. One is the x, and this is a placeholder. Then y true. This is also tf dot placeholder. Then we define the first layer. Then perform the computation using the function we created above x into xw plus b. uh, then see convolution layer output, and then 55132, and this ReLU layer. Then we have to reduce the spectacle size using create the first pooling layer and reduce the spectacle size. Then we have to, one second. Okay, so first fully connected layer we have to make. Okay, then see here we have make the then first pooling layer, then reduce the spectacle size, then we create the second layer, and then second layer reduce its size, then flatten the data and making it fade into the first FC layer. The important point to note is like we have reduced the size 8 into 8 into 64. Then we created the first FC layer, ReLU layer, and this dropout. And finally, at last, see, at last we have to make the testing and training of the data set. For this, we initialize and we use the tf.session to train the uh, test CNN. Okay, so for this, we use the 5000 step, and then we use 100 for every after every 100 steps we are running the testing and tested the accuracy, so that on every step the accuracy is calculated. We can see the accuracy started with 10%, then 38%, then 42%, and then it goes on. And we can see it's after that at the end the accuracy comes to like 68%, 69, 67, 66, and finally it was around 68%. So it was not much. We have to improve this accuracy. Let me go through one of the document. So if we see what is this our architecture. So architecture, we have to input the data, and then we have to see input data is training set, training level, test data, test level. Then we have to perform, this is the architecture. Then similarly, this is a layer, one layer, two layer, then pooling layer, then finally fully connected network is uh, formed, and then output. So as a high level, if we see what is the step to build the CNN, then build the CNN network is the phase one. We create the first convolution layer that uses ReLU as activation function. Then we create the pool that work hand in hand with the convolution layer. Then we have to repeat first until we got the both the layer has been created. Then we have to create and reshape and flatten layer to output from the last pooling layer. Then we have to create the fully connected layer. And then we have to repeat the step to where other fully connected layer. Then we have to create the dropout layer, and finally all together we can use an optimizer to optimize the network. And finally our AI deep learning trainer is created to train the network. Then phase 2 is just train the our CNN network and calculate the accuracy. We can see our accuracy has been created. So, and finally if we go there, it's 66.85. And this is our my part 3.